Well, thank you very much. So we are going to have both Bob Ellsworth and myself, Larry Mead, do this presentation. We're going to sort of tag team this, so we'll switch around a little bit. And I'll go ahead and jump right in there and get to what we're going to cover. What we're going to cover is first off, we will introduce ourselves and why people would care about hearing people from Microsoft talk about what to do with their mainframes, in digital transformations for government. That will be the platforms we cover. We'll look at, the different goals that you go through for, transformations and the options, because not everyone's the same, especially in the mainframe world. We'll go into some transformation details, how you actually do it, and then we'll get into summary. So with that, I will ask Bob to introduce himself.
Thanks, Larry. So my name is Bob Ellsworth. I lead the Mainframe Transformation Initiative here at Microsoft. I've had a long career on both mainframes and also Microsoft, going back to 1971, where I worked my way through college at Virginia Tech, maintaining an IBM mainframe. In fact, the picture you showed on the previous screen looks like a 360 Mod 30, which is the first mainframe I started working on back in 1969. But enjoyed working on mainframes for 30 years, and then came to Microsoft to drive improvements to Microsoft offerings to be much more enterprise credible and capable. I'm a patent holder, 3 mainframe patents that IBM cross licenses, and helped drive improvements here at Microsoft again for enterprise credibility. I started a mainframe migration practice here at Microsoft back in 2008, and we'll talk a little bit about what we've done since then. But it's been a real pleasure combining the mainframe skills, the Microsoft skills, to help customers take advantage of the latest technology.
Okay, and briefly introduce myself. I'm with Azure Engineering, a group called Critical Infrastructure. And I don't quite have as many years on the mainframe as Bob. I had about 17 years before joining Microsoft over 25 years ago. And then what I found is that if you knew about the mainframe when you came to Microsoft, people kept asking you how to help get workloads moved from the mainframe. So I've done a lot of work with that and done a lot of work with government solutions over the time. So that's my brief history and why we have some experience about doing these things. So the first thing that I want to talk about a little bit is, okay, if you're considering some kind of a modernization or transformation, those are the kinds of words that we use, not really migration. What are you going to put this on? What are you trying to do from a point of view of infrastructure in order to support this? Okay, so it's very important that if you're going to choose a cloud platform for doing this, that you've got the coverage that you need. And certainly Microsoft Azure in the United States has a very good coverage and here, and also has very good coverage for what we call our government cloud. But we also have worldwide coverage if that's something that you need to look at. And if there's any one on from Canada, we do have people from Canada who also can be, can work with our customers. We have regions there. So, we do have that sort of presence that gives you this. And we have multiple what we call availability zones. So that means you can have highly available architectures that are then put into Azure to meet the kind of availability and reliability that you expect on if you're coming from the mainframe. So the next thing I want to talk about really briefly would be the fact that for government, we have a lot of things that we do specifically for government, okay, that we get a number of certifications for government, and we do it for the US government, obviously, but also for other governments. For instance, we have Australia certifications too. We have certifications from Canada, the EU, and even China, Germany, Japan. And these are all the things that we need in order to make sure we've got the capabilities. Now, I want to just briefly talk about the fact that we have more than one type of implementation that we can do with Azure in government. In fact, we've got 4 different implementations that we can do with Azure in government. So we've got regular commercial Azure. That's the one that's in all the regions all over the place, and it does have FedRAMP, PATO type certifications, and can host a lot of government systems. That, in fact, that's probably the place most of our customers go to first. Now, that said, not every system a government has. There's certain regulations that might require something that would be done where, like, information is not shared, outside the United States boundaries. So that's where you get into our government regions. We have government itself, which gets into higher levels of security and isolation. And then we also have the secret, which again even has higher levels of security, and we get into the top secret, which we also have available or is going live soon. This is where we're getting into things where we're actually air gapped from everything else that's being done out there on the cloud. So you have isolation. For instance, there's a completely separate set of applications from a point of view of how they authorize and authenticate on the government cloud than there are on the commercial cloud. So you can have a high degree of isolation as you're being able to deploy these systems. So I guess the point that I'm trying to get here is that you do want to have something that meets the needs of being able to host these types of applications, as well as just having the systems that can run in those cloud platforms that perform the functions that your systems that are currently on the mainframe do. So, some of the attributes that we look at here is that we want to have, the high level of availability in the data centers. We want to make sure that the services in our government cloud are also available, are available as soon as possible when they come out in the commercial cloud. The commercial cloud will always be deployed first, but we are keeping parity to be very close to what we have in our commercial cloud. I think it's very important that we support our hybrid type cloud and on-premises. That's because people don't migrate everything at once. If you're a large system, you probably do it over time. Now, some systems are possible that they can be moved, perhaps over a downtime on a weekend or something like that. But there's still more that need to go through a transition process in order to make sure that you're spread across multiple regions and things of that nature. Now, some of the other really important things is it does give access to our fiber network, means it's fast. We do have the native type edge type capabilities, so that you can actually deploy edge devices, in areas where there's not already a data center, to then take advantage of some of the cloud features and then use that to then connect into our cloud. So we do all that with doing all the work that we can provide with being compliant around access control and intrusion detection. I mean, we always assume that you never assume you cannot be compromised. So you always are looking at ways to keep the things from being taken advantage of, even if there is an intrusion. Just some of the thoughts that go through the various things that we do as far as making sure we've got that cloud platform that these types of systems can be deployed on. And with that, I'll turn it over to Bob to start talking about the platforms we cover.
Yeah, thanks, Larry. So when we think of just the terminology, mainframe and mid-range, it's pretty specific in this industry. Mainframes that we primarily cover are the IBM Z series and the Unisys ClearPath. From the Z series, of course, multiple operating systems that Larry and I have worked on over the years. The same with the Unisys ClearPath, and that's one of the primary areas of our focus. Along the mid-range computers, IBM Power Systems, both System I and System P, which all runs on the Power 9 chips currently. The Spark system, both from Sun and Fujitsu, AIX system from Superdome X from HPUX. And so those are all some of the platforms that we primarily focus on. And the beauty is we've got solutions for all of these platforms and paths to modernization. So whether it be rehosting, refactoring, re-architecting, those are the solutions that we typically lead with as we engage with customers such as yourselves. One of the very unique solutions is on the IBM Power Systems. We actually purchase Power Systems from IBM and put them in Azure. And so those are available in our Azure data centers, and we have tooling through SkyTap to migrate an existing LPAR off an on-premise power system onto the Azure Power System. And the beauty is this is then in the Azure cloud, and the surrounding systems have low latency in connecting to it. Go ahead and move to the next slide, Larry.
I just thought you might want to hit the last piece there, the little surprise. We go from small systems like 100 MIPS, that's millions instructions per second, to really big ones over 100,000 MIPS.
Yeah, we sure do. In fact, one of the biggest ones we're working on right now is 300,000 MIPS. So pretty amazing spread of customers' usage and also the ability to move these workloads. And so when we think of the goals and the options, the challenges customers face on the next slide, like yourselves, and these are probably familiar to you. Definitely, the cost is one of the biggest challenges historically our customers have had, and the reasons they look at moving workloads off of these mainframes in mid-range is just because of the increasing costs and the cost to keep these systems current. Skill shortage has become more and more apparent and driving customer interest in moving off these legacy systems. Just the difficulty in finding programmers to take care of maintaining the applications and also the operating system itself. People that know COBOL and assembler and other languages, such as IDMS and ADABAS, are harder and harder to find. Yeah, more and more customers are interested in going to a more flexible architecture, moving off these legacy systems to a standard x86 platform, so they can embrace things like deploying in the cloud, and then being responsive to the business. But today, when building or maintaining an application, doing that in a modern DevOps environment, where you can roll out incremental changes to support the business needs, it's difficult to do on a mainframe where you've implemented a waterfall process for doing updates, on a once a year or maybe once every 6-month basis. Next slide. A lot of times you wonder, well, why Microsoft and mainframes? You wouldn't think Microsoft would be in this space. As I mentioned, we started our practice back in 2008. And over the last 12 years, we've built an ecosystem of partners with tools and services to help with the most difficult migrations of these workloads off the mainframe and the mid-range servers. So what Microsoft acts is a trusted advisor, ensuring through these experiences that you select the right solution, the right partner ecosystem to be successful in doing these migrations. The next slide. When we think of the path to migration, every one of your environments is unique. There's certain patterns that we encounter repeatedly, but every customer's environment's unique. No matter which operating system you're running, whether it be ZOS or ZVM or even TPF, which we've seen in several organizations, and Larry and I have assisted customers with, or zLinux, on the Power Systems or the Unisys ClearPath systems. Again, standard operating systems, but then what you run on top of that with standard databases, but also unique databases, whether it be ADABAS or IDMS. Those are ones that we run into and have solutions to migrate workloads from. And then the different transaction processors or the development languages, even 4th generation languages that we have solutions to move the workloads off of. And when we think of the path to modernization, this is a journey. It's not one size fits all. But typically for a smaller workload, you'll pick a single method for doing a migration. For larger, more complex workloads, we help you assess each workload and decide on the best path forward to modernize or transform it. In some cases, moving out of your data center is a top priority, and having a remote hoster take over management within your data center, move these workloads into their hosted data center may be one of the first steps you take. You're also always retiring applications you no longer need. You can surround the mainframe or the mid-range with modern BI and analytics, with web services and mobile application access. You can replace your custom apps with packaged apps as long as the amount of customization you need to make is kept to a minimum. And this way you put the burden on the vendor to support those applications. And the areas we spend most of our time in is replatforming, rehosting, refactoring. Replatforming, we've got some unique solutions that can actually take a running system, an x80, a Z-series running system, and transform it to run natively on x86. So very unique solution if you have a packaged app that you have IP rights for, but don't have the source code. This is a good method to use. Rehosting is where you keep COBOL as COBOL and recompile it to run on Windows or Linux without change, so you can deploy it on the cloud. And then refactoring, if your application, programmers are hard to find, skill shortage is the biggest issue, really want to get out of that native language, then refactoring from COBOL to Java or C# is the method used. And the beauty is, again, we have this ecosystem of partners with tools and services to embrace every type of these migration methods. Lastly, once you're able to move workloads off the mainframe and take advantage of the cost savings of running in the cloud, you're then able to reinvest those funds to re-architect, re-envision, rewrite those applications that you want to transform. So this is, again, a journey, not one solution fits all. Really applying the right methodology based on your business needs is the choice that we help customers with. Go ahead, Larry.
Okay, so we're going to talk a little bit about some of the details about doing some of the transformations. One of the questions we often get asked, I mean, almost all the time, is, okay, how do I equate compute on a mainframe to compute on Azure or, on x86 platforms? And so a while back, as approximately 10 years ago, a study was done by Microsoft, Micro Focus, and HP at the time to sort of benchmark a workload as to on a Z-series mainframe, and then seeing what could run on cores on a x86 type platform. So what we found is that a core could basically get about 170, I should say, MIPS equivalents as what you have for batch. Now, most of your mainframe applications will have both online and batch kind of environments. The batch tends to be a little bit more, compute and intensive and I/O intensive. But they also have onlines, and we've got CICS there as the transaction processor that was tested for onlines, and we were able to get almost 288 MIPS per core. So, those are sort of the benchmarks that we're able to achieve. Now, this was done on an on-premises system originally, but this has been duplicated by several of our partners on Azure, and they've actually got slightly better performance. We can scale up to, I think the largest that we have is almost 30,000 MIPS that we've shown that we can take using just regular VMs in Azure. Now, keep in mind, this is basically done at what we would call the LPAR level, in other words, the logical partition on the mainframe. And most mainframes have more than one LPAR. So like Bob mentioned, 300,000 MIPS. Well, that's actually spread across more than one physical machine, and they're running more than one mainframe, I should say LPAR, on those physical machines. So the individual LPARs that even the largest customer that we have really don't get much more than 20 to 30,000 MIPS. So we can very easily handle those types of workloads in Azure, based on the benchmarks that we've done and also the successes that we've had. So it's not just a benchmark that we've run. We've actually been able to go out and prove that with successful migrations too. So that's sort of the first thing with, that we want to do. The second thing we want to do is look at the different types of scenarios that we might have for being able to do this. Do we need to have high availability? Do we need to scale up, scale out? Do we need to have geographic-based disaster recovery? Do we want to use platform as a service to meaning I have to have fewer full-time equivalents to run these in that? Do I need scale sets for VMs? Do I have bursting that takes place within my application, or is it more a 24/7 constant kind of thing? And then, one of the things we find is once they're in Azure, a lot of customers in government, they do want to unlock some of the capabilities that they can do with, native analytics that are available from the cloud. So these are things that are quite often done, after we get the data there. And then finally, we make sure that we are being compliant to the level it needs to happen as you're running in these government solutions. So this shows a high-level architecture, and we do publish these architectures out on the Microsoft Architecture Framework site. And what I want to show is that, remember, we talked about either Refactor or a Rehost type of a system, one where we're either using a partner emulation that's running in Azure, or we've rehosted to, in this case, a Kubernetes cluster with containers running Java. So those can run, by the way, side by side. It's not an all or nothing kind of solution. Some customers decide that they want to rehost some of their applications. They typically do that if they're, say, in maintenance mode. They don't do a lot of work with them, and they don't want to invest a lot of development effort. They probably think rehosting is the right way to do. But if they are doing active development in it, they may want to look at, well, I want to do this in Java going forward. I want to do it in C#. So in this case, it's showing that either one can be done, and then we would leverage the things that we have in a cloud environment in Azure, where we would have a virtual network set up, a VNet, and then we would use our load balancing services that allows us to have not only a scale-out compute, but also gives us the capability of running across regions if needed, and using network services for that. And then within getting the compute being done would be done within the nodes that are running within Kubernetes, or within VMs, typically that could run with the partner emulation. Now that said, this is sort of a recommendation of how it might look. You can potentially take emulation systems, deploy them in containers like a Docker container, load that in the Azure Container Registry, and then deploy that in a Kubernetes cluster. So you can actually take an emulation that normally would run on a VM. If you can Dockerize it, you might want to deploy it in something like a Kubernetes cluster. Well, why would you do that? Well, you get all the value that you get from the deployment that you get with Kubernetes, rather than having to maintain the VMs. And then this just also shows that you then have the capability of using all the different data solutions that are available in Azure. And we can run with third-party relational databases like Oracle or DB2, DB2 LUW, the one that's for Linux, Unix, Windows. But if you want to use a PaaS solution, we've got things like Azure SQL databases, Postgres instances. We have something called Cosmos DB, which is our NoSQL type of system. And we find customers, especially if they're refactoring or re-architecting, might want to use something like a NoSQL solution instead of using vSAM, which is the more of the file system rather than the relational database type storage that's on a mainframe. The last thing I want to point out is, let's say I've got a really large system. Remember, I was mentioning the really large customers. They probably have more than one physical machine, and they might be sort of coupled together with something called a coupling facility, using something that's called parallel sysplex to enable applications with it. You can get similar type of functionality in Azure, and these, we're talking the biggest systems here, by using things like cache, like Redis cache. That allows memory sharing between multiple VMs. So let's say I had 3 LPARs that were on different physical machines, that are connected to a coupling facility. I could be, having those same type of LPARs represented in one of these architectures that then used Redis cache for that memory sharing. So it does allow these applications to move over and allows them to also function very efficiently. Last thing I would mention is that you do want to make sure that you're in a environment where you've got your storage being done in a way that's then redundant if you need it. It can also be geo-redundant. So this just gives you a high-level view of what the actual architecture might look like for both the replatform and rehost and refactor scenarios that are running in Azure. And we've actually seen this done with multiple partners, moving forward. This is, one that we've done also with a non-x86 Unix. This is a solution that we've done with a partner called Stromysys, which then has a solution for running Spark type Solaris. So this would be another way, and then it can be then deployed in Azure. So we've talked a lot about IBM Z series, but it could also be other kind of older architectures, and we do have ways of being able to architect them too. So with that, maybe Bob, you want to jump in and talk about some of the solutions that we have?
Absolutely. Thanks, Larry. And so these are, I'm going to show you 3 examples that are public. You can go to the links to the websites to get more information about these migrations. The first one is Jefferson County. They had an aging Unisys mainframe, and the challenges they had were the cost and the complexity and skill shortage. For them, they worked with Astadia and ourselves and Micro Focus, decided to rehost this workload to run natively in Azure, to move development from the mainframe to Azure DevOps, so they could hire kids out of college that know Visual Studio to maintain these applications, these global applications. And took about 14 months to complete the project, 10 months ahead of schedule. They're saving $500,000 a year and reduced their operating costs by about 90%. So very good success, reducing costs, improving the system, and eliminating the mainframe out of their data center. Move on to the next one. Another great example of a Unisys mainframe migration to Azure, again, was done by Astadia using Micro Focus technologies. This is for the Air Force Material Command. It just recently became a public case study on the astadia.com. Again, I included the link there for you. This one is pretty incredible because not only did they have a skill shortage, wanted to move to a modern DevOps kind of environment, which they're able to do with Micro Focus COBOL, deployed this in FedRAMP for high security. And this system is used to keep track of the maintenance on aircraft and other vehicles. Their whole goal was to increase the uptime of the aircraft, reduce the downtime. So the first step is to move to a modern Azure environment, saving about 75% a year on the total cost. So $23 million a year savings. But in addition, migrated from the proprietary Unisys database into SQL Azure to position themselves to be able to do AI, machine learning, BI against that data, and to do predictive maintenance on their aircraft. So this helps facilitate that long-term goal of increasing the uptime of the aircraft. Move on to the next one. And this is a fascinating one for you, those of you that run Unisys MCP, ClearPath MCP. In this example, migrating this workload, which about 30 million lines of code, was very cost prohibitive to use rehosting like on the previous other examples. Very expensive for a very small mainframe, only 35 MIPS. The biggest challenges were the aging workforce, the older systems in the data center. And for them, what they decided to use was a new offering we have with Unisys, which is to run MCP natively in Azure. In addition, Unisys provides the services to support the applications, to maintain and monitor the system, to run the batch operations. So it took over responsibility for running this very critical mainframe in North Dakota, running this in Azure, giving them the elasticity they need, moving it into a modern development environment, but also providing full support for this environment so the state doesn't have to acquire the skills to support this workload. And this is also a public case study that recently became available. And then next slide, lastly. And this is a new win. It's a State Department of Criminal Justice. What's interesting about this one, it's an IBM Z-series mainframe. They've got skill shortage. They wanted to move their offender management system to a modern environment to improve the caseworker usage, and decided to move that to our CRM system called Dynamics 365. But just moving to the CRM system left the mainframe intact, not giving them cost savings. So we engaged with a Stadium Micro Focus on a rehosting opportunity to move the rest of the workloads up to Azure, in addition to the database used for the offender management system, to give a direct access from the Dynamics system running in the cloud. The most interesting thing about this migration, which is a new win, it's not in production yet, is the customer didn't have the budget to pay for the migration, yet they would achieve significant cost savings of about $5 million a year. So we worked with Key Bank, which provided funding to pay for the migration and only get paid back once the mainframe's eliminated. This way their budget didn't increase, yet the migration could be kicked off, and they would still benefit from the cost savings once the migration was paid for. And next couple slides. But just in summary, hopefully this has been useful for you to better understand, the kinds of engagements that we're driving and the benefits of Azure. And to reiterate some of the benefits of working with Microsoft and Azure is our 12 years of experience driving more than 1,000 mainframe migrations. So through that experience, we can help you make the right choices. Secondly, it's not just Larry and myself. I'm part of Azure Apps and Infrastructure. Larry's part of Azure Global Engineering. But we've got deep technical resources across the entire company that help facilitate, ensure success of these migrations from data R&D and from cloud engineering. And lastly, Larry touched on several of the capabilities in his diagrams of Azure functionality. The importance is that Azure, properly configured and architected, will deliver the same levels of reliability, availability, scalability that you depend on your mission-critical mainframe workloads, in addition to elasticity, modern DevOps, and new ways of deploying these workloads without starting from scratch. Hopefully that gives you some good ideas on why you'd want to work with Microsoft. You'll have a copy of the slides, so you can look at the next slide, which is the sample mainframe modernization journey, to give you an idea of when we work together, the steps that you'll go through. Because we're running late on time, let me just move on to that last slide. Again, Ron will make available to you the slides, so you'll have these handouts, and it'll give you links to the resources, so you can read up more about working with Microsoft and our partners to help you transform from the mainframe